Okay, so hi there everyone. We're now on our next video in the mathematics in the modern world, and we're now touching the module or the chapter in the fundamentals of logic. Okay, in which in this particular video we're going to start with our video or our lesson in propositions. So before we'll start with propositions, let's have this a little bit in mind. Okay, let's have some questions. Why is it important to study logic? So for example, let's just imagine these statements. So statement one would look like would read as penguins are black and white, which is true. Okay, this statement is said to be true, and it is true. We say that we can see penguins, a typical penguin, okay, have black and white as their colors. Also, we know that some old TV shows or some TV programs, so we know even before the colored television, they are black and white. So with this is also true. So since both statements are true, so therefore we can conclude, therefore some penguins are old TV shows. Okay, which is of course a question mark for everything for this statement, since statement one is true and statement two is true, but then their combination of those two statements are pretty wrong. Okay, which will ask us what? Hey, what just happened? So penguins are not all TV shows, and that's a fact. That's a fact. Now, this is where the importance of logic comes in. So we cannot just write some statements whatever we want and then conclude, since the statements are true. So the logical arguments and the flow of logic is quite also important when it comes to the fact or the truth values of it, in which we're going to talk about later. Um, Now let's have some definitions. So definition one is logic. So logic is we can say that it's a branch of math or um, one chapter, a very important foundation of mathematics. It is a study of the principles and methods of governing or and methods governing sorry, correct or reliable inferences. So we're having some conclusions to make sure that our inferences are correct or our conclusions are correct. This includes analyzing relationships and interdependence of a series of statements to properly draw a valid conclusion. Okay, so that is a study of logic. Okay, and again, this is a foundation of mathematics. Let's define then proposition, in which we're going to deal with the next couple of slides. Propositions are declarative statements. Please take note of that. They are declarative statements which are either true or false, but they cannot be both. They cannot be both, and are denoted by a small letter, usually P. Most books use P, Q, R, S for propositions, but you may use any letter in the alphabet. So, for instance, exempli gratia, Latin, you know, how do you write EG? This is the meaning of EG. Okay, exempli gratia, which means in English, for example, literally, by translation. Or sorry, for example. Okay, now we will be identifying which of the following are propositions and which are not. If it is a proposition, tell if it is true or false. So let's have this as an example first. So I'm going to answer. So P. P means, this is our proposition P. It means Manila is the capital of the Philippines. So is this a proposition? So again, take note, a proposition must be number one. It should be a declarative statement. It should be declarative. And one more thing, it should be either true or false. True or false, not both. Not both. So is this a declarative statement? Yeah, pretty much. It's declaring, and this is true. Okay, so thus this is a proposition. Okay, so we can say that this is a proposition, and we say that it is true. Let's denote T for true. Okay, how about the Q? Q is another proposition. We have 12 plus 9 equals 21. Um, is this a declarative statement? Yes, only that it's a mathematical sentence, but it's still declarative. It declares that 12 plus 9 is equal to 21. And pretty much it is also a proposition. Let's state P for a proposition, okay? And we also say that it's true because indeed 12 plus 9 is 21. For R, we say here that Mark Zuckerberg is the chief executive officer, or let's say, of Facebook. So this is pretty much a declarative statement, and it is true. It is true. So therefore, this is a proposition. Let's write this again. Proposition P, and then true. So it's a proposition true. Okay, next is we have the letter S. Are you one of my students in math class? So is it declarative? So pretty much not, because this is an interrogative statement or an interrogative sentence. So therefore, this is not a proposition. So we denote that as NP. Okay, for this example. So P for propositions, NP for not. Okay, so it's not a proposition. So therefore, we move on. How about you? Um, U here, or rather T rather, sorry, T. T stands for go, Karen. So is this declarative? So pretty much not. It's not declarative, so therefore it's not a proposition. Next, if you don't live here, then please don't park here. So is this declarative first and foremost? So you can see if you don't live here, please don't park here. So it's telling you to don't park here. So this is imperative, an imperative statement. So this is not a proposition because it's not declarative. So therefore NP. And we have V, keep your eyes open. Keep your eyes open. So again, it's imperative. It's not declarative, so therefore it's not a proposition. And how about W? It states here, this statement is false. So is this declarative? Yes, pretty much it's declarative. Is it true or false? Okay, let's try to think. Um, when this statement is true, we don't know if it is true or false, right? So if imagine if this statement is true, it says that this statement is false. So it is true that it is false, giving us the truth value of false. Now, this statement is false. Now look at it again. This statement is false. We have established that it is false, but the statement again says that it is false. So since it is false, and a double false, a double negative, it gives us true. Again, this is true. Reading the statement again, this statement is false, therefore it becomes false, and therefore it becomes true. So again, it goes back and back, and so on. So meaning, in short, it is not true or false, not either true or false, but it's both true or false. So this is still not a proposition because it is not either true or false. It's both true or false. And these statements are what we call paradoxes. This is called a paradox. A statement which is both true and false. So these are some examples of how to identify if it is a proposition or not. So I think it's your turn to answer this. I'm going to give you time to answer this. Kindly pause your video and try to answer it yourself. Okay, so I think you have the answers now. So still exercises, identify which of the following are propositions and which are not. If it is a proposition, tell whether it is true or false. So number one, the average of 5 and 7 is 12. Okay, so it is, again, let's write here. Number one, it should be declarative, declarative. Number two, it should be either. Let's emphasize that. Either true or false. So this is declarative. Okay, check. How about if it's true or false? Actually, the average of 5 and 7 is not 12 because it's actually 6. So even though it's a proposition, yeah, that's correct, but it is false. Okay, because it is false, so therefore it jibes with the conditions of how it becomes a proposition. So it's a proposition false. Number two, Liz, can you lend me 100 pesos? So it's not declarative, therefore NP. Okay. Number three, yeah, hey, it's not declarative NP. Number four, squares are rectangles. It's declarative. Okay. Is it true or false? Okay, actually that's true. So we have P true. Number six, please turn off your cellular phones. Not declarative. Therefore it's not a proposition. Number six, teachers are our modern heroes. So that's declarative, and that's a proposition. What is it? True or false? It's true. Okay, no doubt about it. Okay. Number seven, the slope of the line in f of x equals 3x minus 5 is 5. So it's declarative for number 7. So we'll write P here. Is it true or false? Um, actually, it is, well, it is false. Okay, it's proposition and it's false. Number 8, quadrilaterals have 4 equal sides. So we say that it's a proposition, it's declarative, and quadrilaterals have 4 equal sides, not necessarily, because, um, oops, sorry. I have the answers here. Sorry. Let's move on. So quadrilaterals have four sides, but not necessarily equal. Only squares have four equal sides. So it's not true. Number nine, why is this life cursed? So that's very dark. That's not a proposition because it's interrogative. Number 10, the logarithmic functions are the inverses of the exponential function. So this is a declarative statement, okay? And it's either true or false, that's correct. And it's actually true. So if you want to check the answers, we have it here. Okay, so number one, we are correct. That's false, not a proposition, not a proposition, true, not a proposition, proposition, true, proposition false, not a proposition, proposition true. Okay, so that's our answers for this exercise. Hopefully you got a score of, 7 or up. That would be great. That would be great. Okay, next in our definitions is that we're going to define simple and compound propositions. So let's define the simple first. Simple propositions, also called in some books as atomic propositions. Obviously, it's the basics, the most basic of types of proposition, is a statement which only contains one functional part, or shall we say one idea. One idea. So that's a simple proposition. For the next proposition type, which is the compound, a compound proposition, in some books they call it complex proposition, is a statement which contains two or more functional parts or ideas. Okay, so it has two or more functional parts, which are actually, um, you can divide them into two simple or three or more, or two or more simple propositions, but they are glued together, stick together by what we call logical connectives or logical operators. Connectives or operators. Okay, so they are made up of parts or component propositions. Those component propositions are simple propositions. So they are glued together by using logical connectives. Okay, so that's why there are two or more, because they're composed of two simple propositions, three simple propositions, and so on. So let's have some examples here. Determine which of the following are simple propositions and which are compound propositions. So let's answer first. Example number one. Some houses are made of bricks. Is this a simple proposition or compound? Um, how many ideas does it have? Simple again, only one idea. One idea. Compound propositions have more than one idea. More than one idea. Okay, so meaning two or more. So how many ideas does it have? This only have one idea, so this is just a simple proposition. Let's call S for simple. Let's see. Let's write C for compound. Number two, all women are capable of giving birth. How many ideas? Only one or more than one? Actually, that's only one. So this is a simple proposition. Number three, if a square has four sides, then it is a quadrilateral. So how many ideas? Only one or more than one? We have here a square has four sides and it is a quadrilateral. Therefore, oops, sorry. Therefore, it's a compound proposition. For number four, either a person will eat pasta or a burger steak. So how many ideas? Only one or more than one? We have here a person will eat pasta or a person will eat a burger steak. So that's two ideas. That's a compound proposition. And number five, Maria is a laborer if and only if she works in a factory. So we have two ideas here that makes it compound. Okay, that makes it compound. Next is, notice in 3, 4, and 5, they are compound prepositions. Look at the the words or the phrases that we did not underline. We have if, and then we have either or, we have if and only if. Okay, these words that I have encircled actually are some examples of what we call logical connectives. Okay, and we have five types of them. Okay, five types of them. These are the types of compound propositions. So we have the negation, the conjunction, the disjunction, the conditional, also called implication in some books. Implication. And we have the biconditional, or in some books they call it by implication. By implication. So we have the words in which we call this the logical connectives in sentence form. So for the negation, it means the word not. And in symbolic form, it uses either the tilde, okay, or this symbol here. Okay, so if you want to negate as a proposition P, so you write this thing here, or this thing here. Depends on the book. Some books use this, some books use this. Okay, for the conjunction, usually we use the word and for that. Okay, and others with a similar um, context with the word and. So we use the cap for that. Cap as in CAP. This is the tilde here. The tilde is actually this one. I'm not sure what this is called. Okay, so this is the cap. So we use P and Q, or we read it as P cap Q. But I think it's better to read it as P and Q. Disjunction is we are using the word usually with or. If you want to use the word neither, so it's okay. Or unless here we use the cup, CUP. So or we can read this as um, P or Q. Okay, this is not P, this is P and Q, this is P or Q. Now for the conditional, we have if and then. Notice that in the conditional, um, we need to have two values here, two propositions. So if, when we write this, when we're going to use the if then um, uh, in sentence form, we're going to read it like this. If P, P is a proposition, imagine it as a declarative statement, then Q, even though we write it as this only. So it's a right arrow, okay, pointing to the right. So if we're going to read it, if we're going to use the if then, it's going to be if P then Q. But we're going to write it as this. Okay, so imagine if you have a right arrow, imagine that there's an imaginary if there before the P. If P then Q. Okay, or maybe you can use the word implies to make it better. P implies Q. It's just fine if we're going to read it like that. Take note, in some books they use the double lined arrow. It's totally fine actually. Depends on the book. Okay, so this is the right arrow. Biconditional is if and only if there's no other um, shortcut for that. So or maybe you can want that if IFF in shortcut for or an acronym. But other words for it, I think this is the most famous one. So we use the double arrow, a double arrow. So it's pointing left and right. Seldom, again, in some books they use this one with the double lined arrow. It's totally fine. Okay, so let's have some examples, shall we? So some examples say we will let P stands for I study and Q stands for I get good grades. So again, P stands for I study, Q stands for I get good grades. So for let's answer these. If you can kindly answer this, maybe you can pause the video and try to answer it yourself. Okay, now let's try to answer this. What we will do is to convert this into symbols. So how do we do this? I do not study. Look at the word not. Every time you look at the word not, it's a negation. I will use this symbol instead of a tilde. It's either way, they're the same. This one here. So P is I study, Q is I get good grades. So since there's a not there, so therefore, how do we write this in symbolic form? We write this as not P. Okay. Number two, I study. This is our P, and notice the end. I get good grades. So how do we convert this into symbols? So we have I study is P, P, and I get good grades. So P and Q. Number three, I study. Still again a P. We have the or. I get good grades. So P is I study again. Or is your cup, and this is your Q. So P or Q. Okay, number four, if I study, then I get good grades. So again, we have the if here. Let's have it as an open close parenthesis, and the then is where we will put the right arrow. So what we have is if I study, then I get good grades. So P implies Q. Number five, I study if and only if I get good grades. So clearly enough, that's your double arrow for the P and Q. That's the if and only if. In some, they would call it's the necessary and sufficient. Okay, it's necessary and sufficient. Also, it's like that. It can be read like that, but that's very long. Okay, another example. Um, let P be Maria is the CEO and Q be John is the CEO. Okay, so let's have these sentences here. Maybe you can also pause the video now and then try it yourself. Okay, so let's answer this right now. So we have Maria is not the CEO but John. Okay, Maria is not the CEO. So we have this statement P. Maria is a CEO, but it's telling us not. So therefore, let's have the not here. So we can read the first part as Maria is not a CEO. But what is but? But is the end. But is the end. So not P and Q. Okay, so again, Maria is not the CEO, but John is. The context is John is the CEO. So we don't really necessarily to write literally the whole sentence. Okay, we just need the context or the idea of where the statement is coming from. So we're telling that um, Maria is not the CEO, not P, but John is the CEO. Okay, number two, not both Maria and John are CEO. So not both. So we have the not here, not both of them are CEO. So not both of them. So therefore, since we're talking about both of them, so we need to enclose P and Q. Okay, not both of them. Okay, not both of them are CEO. Okay, so not both of them are CEO. Number three, we look at this at both Maria and John are not CEO. Okay, both Maria and John are not CEO. Okay, so the context here in number two is that not both Maria and John are CEO. Um, Meaning, um, it can be possible that either one of them. Okay, it's not gonna be not both of them at the same time. Okay, not both of them at the same time. Meaning, only one of them is the CEO, not both of them. Here, both Maria and John are not the CEO, meaning it's clear to see that it's not Maria, it's not John, which are the CEO. Okay, again, for number two, what we're talking here is that not Maria and John at the same time are CEOs. Number three, both of them, each one of them, um, either Maria or John or both of them cannot be CEO. So how can we write that? Not Maria is not a CEO, and John is also not a CEO. Okay, you may think that in number two, sir, it's the same. We will just need to distribute the not, but it doesn't work like that. It doesn't work like that. That's one of the De Morgan's law. Okay, maybe you can try to search up about De Morgan's law. So it's not going to be like this. Number four, neither. So neither is still a negation. Maria nor. So we have a nor now. It's not and. So therefore it's a cup. John is the CEO. So neither Maria nor John is the CEO. So neither Maria nor John is a CEO. Actually, 3 and 4 are one of the same thing. Okay? That is, we call them that they are logically equivalent. We use the three parallel lines for that. Okay, in which if we can, we will reach this part. Okay. Number 5, either Maria is not the CEO or John is not the CEO. Okay, so either Maria is not the CEO or John is not the CEO. So how do you write that? Maria is not the CEO or John is not the CEO. Okay, so we have this also actually in context 2 and 5 are also logically equivalent. Okay, logically equivalent. So for example, for 3 and 4, we say that not P and not Q, if we're going to read the context, is logically equivalent with not P or Q. And actually, these are the De Morgan's law. De Morgan's laws. One of the De Morgan's laws. It's two of them. Okay, and you will eventually see that 2 and 5 are also De Morgan's laws. Okay, so that's beyond our topic for now. But here I'm going to give you some assignments to do. Kindly do this. Okay, I will be answering this, or will be answering this in the next video. Okay, or maybe we can answer this right now. I'll just give the last one for as an assignment. So we will translate the given statements in symbolic form. We use small letters PQR, which are given here, to represent each of the component propositions. A component proposition is a single proposition from a compound proposition. So we say the two lines A and B are parallel. This is our P clearly. Two lines are parallel. This is our P. We have the if and only if. If and only if is the double arrow. They are coplanar. Okay, that is letter Q. Clearly, they are coplanar. And so we have the end here. This is our cap. A and B do not intersect. So notice our R as A and B do intersect. So meaning this not still have the negation, and this intersect is this major this component proposition here is the R. So how do you write that? P if and only if Q and not R. But we need to enclose this in the parentheses because in context, as the meaning of the sentence um, suggests, two lines are parallel if and only if they are coplanar and A and B do not intersect. So they are coplanar and A and B do not intersect. So this form here is a single idea. We may think of it as a single context of ideas. So therefore, this is our answer. P if and only if open parenthesis Q and not R. Okay, and this one will be our assignment. I will be giving this to you. Um, I'll be giving this to you as an assignment. We'll be answering this in the future. Okay, we'll be answering this in the future. Okay, so that's it for our video for today. Quite a long video, but I think we have understood a lot, hopefully, with this lecture. So that's it for today. Thank you very much for watching, and hope that you would like and subscribe. And see you soon for us to answer this. Okay, thank you.